Hello, I'm JW, and in this part of the series on protective devices, we're going to be looking at fuses. Now, fuses are very simple devices. Essentially, it's a small piece of wire which, when current passes through, of course, it will heat up due to the resistance of the wire, and if too much current passes through, it will either melt, or if you put a huge amount of current through, such as in a short circuit situation, the wire will essentially vaporize away, and of course break the circuit as well. Now, there's two main types of fuse, and this type is a rewirable fuse, and these are very common in the UK, and there's plenty still installed. So this is a Wireless one, but other makes, of course, were available. Here's a MEM8 variety, and there's the little ceramic carriers inside there. But the principle is the same. You simply attach to the piece of fuse wire between the two metal contacts, and in the event the fuse blows, then you have to pop down to Woolworths and purchase the fuse wire for 11p, and then of course you have to find the proper tools and unwind a piece of this wire, attempt to thread it back through the ceramic carrier, and of course tighten up the ends there properly and not break the wire in the process, all of which of course in the dark at night, because obviously the power has gone off, and no doubt you probably couldn't find the proper fuse wire at all, so old bits of hairpins and any old bits of metal and tin foil and who knows what else could be shoved inside there. So not entirely practical, but nevertheless vast numbers of those were installed and many are still in service. Now the other type of fuse, which is a tad more convenient, are the cartridge fuse style. Here's a small one from a plug, and of course larger sizes are available. This is a fairly moderate size 80 amp variety, but the principle is the same. The fuse wire is actually contained inside here, which is a ceramic tube. They're also generally filled with sand or some similar material to absorb the energy when the wire breaks, and two caps on the end, and of course you just go and buy this as a pre-made item, just slot it back into the appropriate holder in your fuse box. Now of course you can't go to Woolworths anymore and buy fuse wire, but of course many other types are available. And on this particular card of Panda fuse wire, you can see that the 5 amp type at the top is considerably thinner than the values below, and if you look at the 30 amp one at the bottom, again that's by far the thickest of the lot. And this is simply because the larger wires will obviously take a larger current before they heat up and melt through. And the idea with fuse wire and of course other devices is that the fuse wire will melt before the cables in the building do, and of course it's there primarily to protect the cabling. Now a 5 amp piece of fuse wire will carry 5 amps for pretty much indefinitely. Of course that's what it's designed to do. But if you say put 6 amps through there, the fuse wire is not actually going to melt or do anything else. It will just simply get a bit hotter than it would have done when it was running 5 amps. And this is simply because it's just a piece of wire. It doesn't have any magical properties which can instantly determine whether the current has exceeded some arbitrary figure which somebody gave it. And it's the case for all types of fuse wire and actual fuses as well, that the time for the wire to melt can actually be very large. Certainly in the case of, say, a 5 amp fuse with, say, 5 or 6 amps going through it, it might actually never melt. It would carry that small overload pretty much indefinitely. And even if you, say, put 10 amps through there, it's again not going to melt straight away. It could take many minutes or even an hour or so before the wire actually melted through. Now the actual time that fuses take to fail for various currents can be easily found, and here's a graph showing that. This is for fuses made to British Standard 3036, which is the rewirable style, such as this Wireless example. And this particular one is a 5 amp fuse and has 5 amp fuse wire inside. And if we look at the graph here, you'll see that there's a line here marked 5 amps. And along the bottom here, we've got the current in amps there, so 10 there, 100 there, and so on. And along the side here, we've got the time in seconds that it would take the fuse to actually fail, starting down at the bottom with very small values, 1 second here, 10, 100, and so on. So up at this level, we're looking at a couple of minutes. And over this side, we've got a small table here which has some of the more common values for various currents and lengths of time. So for the 5 amp rating, for example, if you pass, say, 13 amps through there, bearing in mind that's nearly 3 times the rating of the fuse, it will actually fail in 5 seconds. So certainly not instantaneously, and even at something like 18 amps, it's still going to take around 1 second for that wire to heat and melt through. And of course, as the current increases, the disconnection time reduces accordingly. So for example, at the putting 45 amps through there, it should disconnect within 0.1 seconds. And again, you can see this on the graph here. It's just simply a question of this line where it intersects with the time and the current along the bottom. Now here's a 30 amp fuse with the red dots on there, and the 30 amp fuses correspond to this line. And if you say pick a value here of say 100 amps passing through there, which is of course more than 3 times the actual value of the fuse, if you just simply follow the 100 line up here, and it crosses just below that line there, which in terms of seconds here, it's actually going to be around 3 seconds, which is quite a long time in fact, because say that would pass a substantial current through whatever wiring you have in the circuit for around 3 seconds. But of course this isn't generally a problem, because although the wiring in the house will heat up, they are of course not going to be damaged by that, because it's only for a fairly short duration. And the whole point of these is that they will disconnect within a predefined time, and all of this of course is taken into account when you're selecting the cable size, and it's unlikely that you're going to have cables which are going to be damaged by any kind of overload for a moderate length of time. And even, for example, the longer disconnection times up here, so for example here, which would be the equivalent of putting 10 amps through a 5 amp fuse, the disconnection time here is going to be sort of a minute and a half or so. But again, that's not going to be a problem, because cabling generally used on a 5 amp fuse is not going to be damaged by putting 10 amps through it for say 1 minute or so. The cable's going to get quite warm, but also not going to melt or catch on fire. Now that's how fuses are supposed to work, but in the next episode we'll be taking some actual fuse wires and putting various currents through them to see whether those claims are actually true or not, and of course how long they take to melt and what currents it does take to melt them much more quickly. And we'll also be putting some much higher currents through there to attempt to vaporize the wire pretty much instantly, as in the situation of a short circuit. So until next time, thanks for watching.